This is part 2 of section 4.1. We were talking about solving systems of equations, and we were talking about, in theory, how we can solve them by graphing. And now I spell it out. One method for locating the point that solves both equations is to graph both lines on the same coordinate system. The point where the two lines cross will be the solution. Now, admittedly, this is not the most practical way to solve a system, but it is the theory behind solving a system, and it is the language we use every time we're talking about systems. Okay? Now, there are a couple of special cases. It is possible that our lines never cross. If we have parallel lines, they're never going to cross. If they never cross, and our solution is where they're supposed to cross, then we end up with no solution. We say that the system is inconsistent. Okay? We're going to work one like this. If the two equations represent the same line, then that would mean that they have every single point in common, so they would cross at every single point. Then there are an infinite number of solutions. We say that the system is dependent, and we have to give our answer in set builder notation. We're definitely coming back to this. Don't worry about it just yet. Okay? Now, we did work one problem. Well, actually, I think we worked two. Okay? And what we did is we graphed these two equations, and we found out where they crossed. Now, I'm going to remind you a little bit about how the things we have to graph. Remember your slope formulas? Mainly when we're graphing, we're going to be using rise over run. Rise is your up-down movement from one point to another, and run is your left-right movement from one point to another. We tend to solve these or graph these using intercepts when we can, because we plug in zeros and solve for the x and the y. This is because zeros are always nice. It's usually the easiest way to do it. Okay? Sometimes you're going to get ugly answers here and you're not going to like them. And you can also go back to slope-intercept form, where we solve for y. And once we've done that, we can read our slope. And if we know our slope, we can use rise over run. And b is always going to be the y-intercept. Okay? So we sometimes use a combination of these. Okay, so what did we do here? On our first equation, we plugged in zeros, and I color-coded these. So this is blue, which is our first equation. If we plugged in x equals 0, that x essentially goes away, and we ended up with y equal to 4. So our answer is 0, 4. Your answer should be ordered pairs, okay? And you know it's supposed to be x and then y, so don't make that mistake. Then we go and we plug in 0 for y, and when we do that, this y goes away, and you end up with x equals 4. So x equals 4, it's x and then y, so 4 and then 0. Okay? One thing I do not want you to do, I saw this on the test. A lot of you made that into 4, 4. That is not correct. Our intercepts are where our lines cross the axis. And if this would be saying they cross at 4, 4, which would be right here, which is definitely not on either axis. Okay, so let's go back to this blue line. We plotted 0, 4, which is here. We plotted 4, 0. We felt pretty confident about these, so we drew a straight line. We did basically the same thing for our second equation. We plugged in 0 for x, and negative 0 goes away, so y equals 4, 0, 4, which is here. Now, we knew this point was in common, but it's not enough to say that's our answer, because it is still possible that we have the same line. This is definitely at least one of our answers. Plug in y equals 0. If you have y equals 0, the y goes away, and you end up with negative x equal to 4. And remember, when you have solved for negative x instead of x, you just change the sign on both sides. So that gives me negative 4, 0. We plot our 2 points, 0, 4, negative 4, 0, connect them, and they cross in exactly this point. So our solution is the point 0, 4.